We're now going to talk about how to evaluate limits numerically. And so first, I already have the numeric values filled in, although I am going to show you a couple features on your calculator just to make sure that I think you're doing this in an efficient manner. And this number 7, so what we first see here is that the function we're looking at is the limit as x is approaching 2 of, and my function here is x squared minus 4 over x minus 2. Okay, so this is the function f of x that we're talking about. So the first thing we're going to do is we're just going to sub in numbers, but I want you to not lose sight of the fact we're doing numerically what we were just doing visually before. So what I want you to think about is these x's right here. These are x's that are getting closer and closer to 2 from the left. And then the numbers over here, these x's, 2.1, 2.01, 2.001, these x's are also approaching 2, but they're doing it from the right. Now, it just so happens here that at x equals 2, if you were to sub in 2, you'd have 0 over 0, so that the actual point doesn't exist. But remember, we don't really care if the point exists or not when we talk about the limit. We're just talking about what are the y's potentially getting infinitesimally closer to here as we get closer and closer to these x's from both sides. So the question we are looking at is potentially, as we look at the output values, are these y values potentially approaching the same number from both sides? So the question here is, what are the y's approaching? That is what we are looking at here. Well, 3.9, 3.99, 3.999, that's getting closer and closer to 4. And 4.1, 4.01, 4.001, and so on, that is also getting closer and closer to 4. So what are the y's approaching here? The y's are getting closer and closer to 4. So that is numerically how we can determine a limit. It's looking at the numbers that your eyes were naturally looking at when we were looking like at graphs up here. Like if I look at the limit as x approaches 1, I was maybe from the left coming at it from 0.9, 0.99, 0.999, and maybe from the right it was 1.1, 1.01, 1.001. But visually your eyes are just doing what we are looking at here with the numbers. All right, so I have another example here. And then again, I'll pop up a calculator so you can hopefully develop an efficient way. There's several ways to sub numbers. I mean, it is just subbing numbers in, but there's a few kind of efficient ways you should be aware of. So on this second one, it is the limit as x approaches 0 of cosine x minus 1 over x. So again, this time that is our f of x. And so what we are once again looking at here is we have numbers negative 1/10, negative 100th, negative 1,000th, negative 0.0001. So what are these x's approaching? These x's are approaching 0, but they're doing it coming from the left. And then if I look at my x's 0.1, 1/10th, 100th, 1,000th, these x's are also approaching 0, but they're doing it from the greater than side. So they're doing it coming from the right. Now, once again, I don't really care about, but just FYI, if you were to actually sub in 0, once again, this is not going to exist, but that doesn't matter for the limit question. So looking at a table of values, once again, we are looking at whether or not these y values, so 0.05, so 0.005, 0.005, so we're looking at those, and then same thing here, kind of from the negative side. So we are looking at what is happening here with these y's. What are potentially these y values approaching? Are they closing in on the same value? And once again here, they happen to be. They are getting closer and closer and closer to 0. The fact that it's, it didn't have to be like the same number with the 5. It could have been that the left was, maybe this was 0.05 and this was 0.003, and maybe this was 0.0002, and maybe over here it was negative 0.01, and then negative 0.007, and negative 0.00048. They're still getting, like, the fact that the 5 was the same, I mean, that's okay, but we're really just looking at the values of these numbers getting closer and closer and closer to 0. Now, if from one side, let's say I was coming into 0, but let's say from the other side I had something that was coming in at, maybe this was, I need my pen there, so suppose this was coming into 0.49, and then this was 0.4998, and maybe this was 0.499973 or something. If you have something like this, these values are approaching 0. These values look like they're approaching from the right, they're coming into 0.5. And just like before, if you're not coming into the same value, you would say that your overall limits, the general limit as x would approach 0, wouldn't exist. But in this case, once again, we can see both of these left and right values are approaching 0. So this overall limit is going to 0. Now, quick comment in terms of your graphing calculator. So if you are going to be subbing in some function, so let's say I already had, I guess, the first one subbed in. So y equals, careful, always imply parentheses around numerators and denominators. And so one way that I like to determine these values, although there's several, is using the table feature. So that's second window. You have a couple of options. In this example, I was interested in what was getting closer and closer to 2. So if you want to have the calculator just kind of fill a bunch of values, you could say, all right, maybe let's start my table at 2, and then change in table, maybe I make the change in table like the difference of maybe 0.01, and then have it automatically fill the independent and dependent variable. So that's one option. So you could look at the table, and then you can arrow up and down, and you can kind of visually see here as you're getting closer and closer to 2 from both the left and the right, you can see those y values getting closer and closer to 4. So that's a quick way